In part B, we're going to look at the equation y equals x. This particular equation is known as the identity equation, and when we write it as a function, we call it the identity function. And there is a reason why it's called the identity function. When we start looking at creating a table, we will see exactly where that comes from. But let's first define a function using the largest possible domain. And I'm not going to be terribly creative in this example. I'm just going to call everything f. And it just so happens the domain here is going to be all real numbers, just like with the constant function. Now, as you look at your equation, you're looking at the right-hand side of this equation where it says x. There is no operations here. It doesn't say x plus 2. It doesn't say x times 3. It doesn't say any of those types of things. It just says x. So what this is saying is that there is absolutely no operation that needs to be done to whatever value you choose. In other words, the value that you pick will maintain its identity, hence why we call this the identity function. So when I define this, I will use the largest possible domain of all real numbers given by the equation f of x equals x. So let's now make our table. X, f of x, and we will have, again, the same values that we used on the constant function will work for most of the examples throughout 2.1 here. And -2 maps to -2, -1 to -1, 0 to 0, 1 to 1, and 2 maps to 2. So like I said, whatever number you pick, it just ends up mapping right back to another version of itself. So it doesn't actually change. So when we graph it, there will be a pattern here. And this pattern ends up being a line, just like the constant function was a line, but the constant function was that horizontal line. This is a line that has a slant to it. And I hear students sometimes call this a diagonal line, which it certainly is at a diagonal, but when we talk about lines, we usually talk about the slant of the line because you can have various degrees of slant. So we'll have a whole section on that later on where we'll discuss more about this particular shape. So this is the identity function.